this is my potential energy reassessment. An airsoft gun with a spring constant of 500 newtons per meter is compressed 4 centimeters when it is loaded. The BB has a mass of 0.3 grams. What is the muzzle speed of the BB when the spring is released? Ignore friction. So this is a before and after picture of the spring. It's compressed here 4 centimeters, and I made a note: the elastic energy stored in the spring converted into kinetic energy of the BB as the spring expands. And then I have my initial velocity is 0, and my final velocity is what I'm trying to find after the spring is expanded. And I have this equation: 1/2 mass times initial velocity squared plus 1/2 spring constant x initial squared equals 1/2 mass times final velocity squared plus 1/2 spring constant x final squared. So then I plugged in 0 for my initial velocity and my final x position, and it canceled out these two parts of the equation because anything times 0 is 0. You can't square 0. And I wrote it down right here just to explain it a little bit better. And then I was left with 1/2 spring constant x initial squared equals 1/2 mass times the final velocity squared. Divided that by 1/2 the mass. That canceled out on that side. And then I did the same thing to this side. I canceled out the 1/2, so that left me with, I solved it for the final velocity. And that left me with square root of the spring constant divided by the mass times x initial. And I plugged it in. The final velocity equals the square root of 500 newtons per meter divided by 0.0003 kilograms times 0.04 meters. And so I had to convert those two. And then my final velocity was 51.639777795 meters per second. And then I rounded it to 51.64 meters per second. And that is my potential energy reassessment.